Thank you for coming to my presentation. My name is Enayat, Kalantarian. I'm teaching math and engineering at Northwest Campus. My project is going to be about an experimental investigation about two of the mathematical modes that I have done in one of my remedial classes. Of course, the modes are going to be just the synthetic, geometric, and also analytic arithmetic. So in this presentation, I'm going to just give you a brief explanation about motivation, why I pursued this project, and a brief introduction about my project, also methodology, result, and conclusion. Now, for motivation, there are many different items or elements or factors for us, for different instructors. Let's say those who are teaching histories, they have different motivations. Those who are teaching engineering, they have different motivation to pursue their projects. These are based on my observation from the experience that I have through the math teaching. So instructor versus the student-oriented teaching. There are practically two methods. We apply two methods. One is the instructor oriented teaching. That means instructor is just picking up the ideas from the observation and brings idea to the class. Students are going to obey. But I don't like that. That's going to be versus the oriented. A student-oriented teaching means students are more involved. The project that I have is getting students more involved rather than I just impose whatever I have in my idea, my mind. Also, another item or level, another factor of my motivation was to find a mechanism to control or to find the obstacles in the students' learning. So that is an honor for each instructor to find out through the classes that what type of mechanism needs to be established in that specific class. Another motivation that really encouraged me to go further was the mathematical cognitions. How students are going to get the idea and how are they going to analyze it, absorb it, and how they're going to maintain it for further than one semester. Actually, they need it for other classes. How do they maintain that idea? Then I was looking for an efficient or yardstick, practically mechanism to probe the students' level of understanding. What am I going to do? What is going to be that mechanism to find out about the students, how much they have learned? What is the scale of what is the fluctuation of the scales? And also putting all together to support and also to optimize the SLO, students' learning outcome. Now, introduction, as a brief introduction, I can tell you that based on our experience, based on my experience, based on my teaching experience in mathematics, many of the students, first-year students, have difficulties to conceptually understand the math. So mainly because of many factors. I'm just going to mention a few of them. They are not familiar with the terminology. They are not familiar with the mathematic terminology. This is one. Also, they are shy. They don't have a good background, but these are different. I'm not going to talk about those. I'm going to talk about just the terminology that it connects their mentality, or they cognitively can connect their mind to the backgrounds. That's weak. So my mechanism, my method, technique is going to find out who is the strength point, also the weak points as well. So putting all together, therefore, I came up with the concept of thinking modes to put all the way that the students are thinking to put them in, categorize them, put them, document them, and also see how they are thinking, what can I get out of their minds, and then go based on that one further. Methodology, in order to apply my method, I needed the students. Unfortunately, I got just 5 volunteers. I had more than that, but they gave up. Then I stayed with 5 of them. I picked up 5 students as volunteers. Then I applied my techniques based on the data collection of 2 ways. One way was interview one by one. I had 15 to 20 minutes interview with each one of them, one by one. Also, I had to transcribed that one. I recorded that, audio taped this. I do have everything documented. Then I transcribed that. Then also I gave them homework to take it home, talking about that homework was talking about the linear equations and also the analysis of linear equations. Then I interviewed them based on what they learned through their assignments. Now what I came up with, I collected all the reasonings derived from their responses. They responded. If you look at that, this one is the interview, and the other one is the assignment. So this is the responses. This is the response that the student A has done. By the way, I had 5 students. I labeled them with not with their name, with just A1 through A5. So now, if this one is giving me the idea that is geometric. That is a geometric aspect. That means over there you can see that this is the synthetic geometry. That's S, synthetic S geometry. SG is synthetic geometry. The other one, double A, is the analytic also arithmetic. So I have collected all those data, put them in, categorized them, and also analyzed them. I came up with modes. So I compared all the students, 5 students, A1 through A5 together, and also I was looking for the difficulties. I was looking for similarities among the modes that I picked up. So if you look at this analytical one and the geometrical one, student A, for example, has 7 analytical one, 4 geometrical one, like that. Since the numbers are very small, I had to magnify the numbers, change them to percentage. So then I graph the percentage. I graph the students' responses in a percentage side. You can see the blue bars are the analytical analysis, the analytical arithmetic, that they are more than or higher than the geometrical one. Now, then I also graphed it based on a different aspect also. I used the arithmetic geometric ratio. I got the ratio of arithmetic with respect to the geometric. You can see also the blue one is the double A is higher than the synthetic geometric. I went a little bit further and I got the error between both of them. What is the error between the double A for interview, and what is the error between the double A and also geometric? So as a conclusion, I can tell that the students were more exposed to analytical analysis, analytic arithmetic than geometrical one, for many reasons. One of the reasons is probably the previous instructors or professors are encouraging them to go by the analytical analysis. They do have capacity to do the synthetic geometry as well. And thank you very much for coming to my presentation.